Welcome back to this delicious section of plate tectonics. Hope you enjoyed your Oreos. Now, as mentioned, plates can interact in one of three ways. They can crash together. It's known as a convergent boundary. That's where you see these arrows kind of coming together. For instance, the Nazca plate crashing into the South American plate, the Pacific plate crashing into the North American plate. These are convergent boundaries. So the Indian plate crashing into the Eurasian plate, helping to create the Himalayas, where Mount Everest is located. So that's a convergent boundary. They're colliding. Now we have divergent boundaries, where the plates are moving apart from one another, dividing, if you will. All along the middle of the Atlantic Ocean, you can see that these arrows are pointing away from one another. That would be a divergent boundary. It's where the mid-Atlantic Ocean ridge is located, the spreading center. It's kind of interesting. It's actually cutting right through Iceland and kind of pulling Iceland apart. But we see divergent boundaries in a number of different places. And then we get transform boundaries. They kind of slide past one another horizontally. Earthquakes are very common here. They're usually in smaller sections, but one of the larger, more famous transform side-by-side boundary is right here in the North American plate and the Pacific plate, right here sliding past one another. It's right where California is located, hence there's so many earthquakes in California. More on that in a little bit. So we have convergent boundaries collide, divergent boundaries they divide, transform tectonic plates kind of slide past one another. All right, so let's talk about convergent boundaries. Convergent, collide. Two plates move toward each other, also sometimes known as subduction zones where these occur, because as plates are converging, typically one gets pushed down, one kind of rides over and kind of gets pulled down, but or the leading edge of it kind of gets pulled down, but the other plate gets pushed underneath back down into the mantle to be melted and recycled. So that's known as subduction, sub below. Powerful earthquakes, big powerful volcanoes, also very common at convergent boundaries. There's actually three types of convergent boundaries, where oceanic crust is crashing into continental crust, ocean crust crashing into ocean crust, continental crust crashing into continental crust. It's pretty easy to figure out what type of crust you got. If it's dry land like a continent, continental crust. If it's the crust underneath the ocean, oceanic crust. Pretty easy to figure out. So you have oceanic crust converging, in this case, with continental crust. Oceanic crust is actually denser, heavier. It's not as thick, it's thinner, but it is denser, heavier. So when they interact, the heavier one gets pushed down, so the oceanic crust kind of goes back down, begins to melt as it kind of gets pushed under, bringing a little bit of water to facilitate melting, which is helping to create volcanic activity. The sheer interaction of these plates crashing into one another also creates earthquakes. Great example of this would be that small but mighty Juan de Fuca plate crashing in to the North American plate, creating a lot of earthquakes and all those volcanoes you have from Northern California up into the Vancouver area of Canada. Mount St. Helens, Mount Rainier, all those big famous volcanoes are all due in part to this convergent boundary. We have oceanic crust to oceanic crust. So when they crash together, something's got to get pushed down. So one of the crusts gets pushed down. But you get these arcs of island, these long chains of typically volcanic islands. A good example of this would be the Aleutian Islands off of Alaska. So this would be oceanic crust. Why? It's under the ocean. Over on this side would be oceanic crust. Why? Under the ocean. And so we have the Pacific plate, kind of going to the northwest, and we have the Eurasian plate going to the southeast, crashing into one another right at this boundary, creating this island arc called the Aleutian Islands. These are mostly all volcanic, and they erupt quite often. No one really lives out on these islands, so there's no necessary threat to human life for the most part, but again, oceanic crust crashing into oceanic crust. And then continent-to-continent conversion. This is an awesome event when this occurs. Continental crust, because it's not under the ocean, continental crust, not under the ocean, can get high mountain ranges, high plateaus, a lot of earthquakes, but not really volcanoes, because you're not really getting that additional water to facilitate melting of the material as it's being subducted and coming back up. So it's just more kind of crumpling things up. Earthquakes common, also large mountain ranges are common, and that's very typical of the Himalayan mountain range. You have the the Indian plate crashing into the Eurasian plate here, and you can see that uplift being created, the Himalayan mountains of which Mount Everest is located. So those are convergent boundaries. Earthquakes common, volcanoes common for the most part. Now we get divergent boundaries. Divergent boundaries, they divide. They get spread apart. Two plates are moving away from one another, sometimes called ridges, rift centers, rift valleys, spreading centers. They're where, again, typically not always oceanic crust, but typically where mantle convection is kind of ripping the crust apart, moving it away from one another. That release of pressure begins to melt some of that mantle material a little bit, and it does fill in the gap here to create brand new oceanic crust, brand new rock, and then again pushing the crust away. So again, typically called a ridge, rift, spreading center, something like that. So you get some earthquakes, stuff is moving, very weak earthquakes, very little, if any, volcanic activity. Again, you are going to get some magma creeping up, but yeah, not too much. So as far as boundaries are concerned, they're probably the most gentle. Great example, as mentioned previously, running right down the middle of the Atlantic Ocean between North America and Europe and South America and Africa is the Mid-Atlantic Ridge, this giant spreading center where these plates are kind of moving away from one another. And again, a cool example is that boundary is cutting right through Iceland, and it's literally tearing Iceland apart. Interesting stuff. And then you get transform boundaries. So transform boundaries, they kind of slide past one another. So this is when two plates are kind of grinding horizontally next to each other in different directions. Strong earthquakes are very common here. Think in California and the San Andreas Fault, but really no volcanic activity going on here. So we have the San Andreas Fault, which sits along a transform boundary. We have the motion of the Pacific plate relative to the motion of the North American plate. And these two plates are kind of grinding past one another. And when that slip occurs along that transform boundary, that's when you get those large earthquakes. What's interesting to note is that Los Angeles is on the Pacific plate, while San Francisco is actually on the North American plate. So I forget the exact value, but I want to say about 20 million years into the future, as Los Angeles moves up and to the left and San Francisco moves down and to the right, in about 25 million years, those cities will actually be neighbors. So if you're around, there you go. Here's a nice little graphic that kind of goes over everything. Continent to continent convergence, oceanic to continent convergence, oceanic to oceanic convergence, divergence, transform boundaries, everything that goes on here. So this is a good summation of all of that. Now, if you would like some additional help, or some additional information, in fact, if you don't want it, please do check these out. Here's some excellent videos. My main man, Mr. Comerford, and the plate boundary wrap. Some hot fire again, hot fire. It really does help understand the boundaries. Convergent collide, divergent divide, transform, tectonic plate slide. Woo! And here's another little song in plate tectonics. It's a Flow Rida ripoff, the whistle song. Please watch them. Again, I know some of these can be silly, but if it helps you understand the content, a little bit, and it helps some of this material get stuck in your head, then it's worth it, regardless if it's silly or not. So let's go ahead and pause here, and when we come back, we're going to talk, finally, about plate tectonics, how they've helped shape Arizona. All right, so bring a little hometown flavor. All right, I'll see you back here in just a minute.